All right, guys, ready? But people online can hear me and see the screen?
Yes, sir.
All right, good. So it's going to work through this paper. Let me get my calculator. So this is the January 2026 exam paper. So this is the very last exam CSEC just this past January. So I guess it's a good gauge of the standard or the level of exam. Not necessarily the question that you will get, but the standard should generally be the same on the paper that you're going to do. All right, so I want to work through this paper. There are one or two questions persons asking about on this paper. That you might want to call special questions because they are rarely set. All right, so I'll see if I can take some time and talk about this. So there's a base question here. And I think somebody asked me about a rotational symmetry question as well. So when I get to those questions, I'll see if I can explain them best way as possible. So if stuff that again, because stuff that we have done in the class before, but maybe you don't remember because they don't come on every exam paper. All right, so let's go. So the first question is asking us to express this thing as a single fraction in lowest term. So this is a calculator question really. All right, if you like calculator question, it is 4/7. It is 4/7 divided by 12. Or 12 is same as 12/1. So the divide by 12/1 is to multiply by 1/12. So it becomes 4/7 times 1/12. I invert and multiply. The 12 is same as 12/1. So this can be simplified. 4 into this goes 1 time, 4 into this goes 3 times. And so it will work out to 1 times 1 is 1. And 7 times this 3 is 21. And we can test that answer by putting the same thing in the calculator here. 4/7 divided by 12. As a fraction, it is 1/21 right here. You can see it, 1/21. All right, so this answer is correct, 1/21. This answer for part A, or part 1. Part 2 now is this base question. So this number is base 4. You can see the 4 there, that means base 4. This is base 7. The best way to do base question is to use place values. Place values. And I want us to know what is the difference in the 3. See, calculate the difference in the value that is underlined. So you need to know the value of this 3 in base 4. You need to know the value of this 3 in base 7. And then you're going to see the difference between them. Now, they did not tell us what base we must put the difference in. So we're going to put the difference in base 10. And when you put the difference in base 10, you have to say it's base 10. The difference is base 10. So the thing to do is get this value in base 10. What the value is in base 10. Get this value in base 10. And then tell the difference. All right? Now, the first thing we need to do now is is to basically use the place values for this one and the place values for this one. It's not complicated. All right? So let me show you now. So we have those two numbers. This is part 2. So we have, let's do it down here. Shift this up. And put this right here. So the part 2, we have 3201 to base 4. And we're comparing that with 6351 to base 7. Now I'm going to put on the place values here for you. Place values. Place values. So the place values, first place value in base 4 is 4 to the 0. First place value is always to the 0. So this number is base 4. So this place value is 4 to the 0. So this number is 1 times 4 to the 0. So it's value 1. This place value, the second one is 4 to the power 1. So this 0 has a value of 0 times 4 to the 1. This place value is 4 squared. So this 2 is really 2 times 4 squared. That's the value of this 2 right now. 2 times 4 squared. Then this place value is 4 cubed. So the value of this 3, you can write it now. These are the values I want us to compare. So this 3 right now, the value of this 3 is 3 times 4 cubed. That's the value of that 3. 3 times 4 cubed, because it is in a 4 cube place value. It is in a 4 cube place. So the value of it is 3 times 4 cubed. Because we're working in base 4. We're doing a similar thing to this number that is in base 7. I didn't have to write out these, I'm just doing it to show you. Right? Because if we wanted to convert it, if we wanted to convert this entire number to base 10, it will be 1 times 4 to the 0, 0 times 4 to the 1, 2 times 4 squared, and 3 times 4 cubed, and then add up those values to get the value in base 10. Then this value, because we're working in base 7 now, this place value is 7 to the 0. So this one means 1 times 7 to the 0. 7 to the 0 is 1. This 5 is in the place value of 7 to the power 1. So you see, you start with 0 and then increase those powers up that way to get the place values. So this 5 value is 5 times 7 to the 1. This 3 is in the 7 squared position, 7 squared. So the value of this 3 is 3 times 7 squared. And if I wanted, this place value is 7 cubed. So the value of this 6 will be 6 times 7 cubed. We're not interested in that. We're only interested in this value right here. That value is really 3 times 7 squared. That's the value of that 3. And that's to base 10. We have worked out the values in our normal base 10 numbers. That's what they are value. That's what they value now in our normal base 10 system. So this value right here, work it out. 3 times 4 cubed, what would it be? I don't need to work it out. I can calculate the difference straight, but anyway, let's work it out just to show you. It will be 3 times 4 cubed. 3 times 4 cubed is 192. So the value of this is 192 to base 10. And the value of this one is 3 times 7 squared. Just 7 squared. Which becomes 147 to base 10. So the difference is this minus this. That's the difference. You subtract them to get the difference. So the difference is 192 from 192 minus 147. The difference is 45. So the answer is 45 to base 10. That's the answer for that one. 45 to base 10. That's what that question is though. That's 45 to base 10. All right. Let's try the answer for this one here. So I can shift this up. So the answer for this one is just 1 over 21. 1 over 21 is the answer for this one. Equals 1 over 21. I'm just going to take this off and shift. I'm going to shift the calculation of this upwards. That is it. But understand that? So the key thing with any number in base is to have the place values. place values. Now, we did a class with this already, right? Needs back here, maybe find back the video and send it to you, but can't go through it fully now. But the key thing to this question, guys, is to bring it to base 10 using place values. And the place, so we work it, if you have a number, for example, say 6, 4, 8, 1, and this is base 5, for example. Then this starts at 5 to the 0. This is 5 to the 1, 5 squared, 5 cubed. So the value of this 1 is 1 times this. The value of this 8 is 8 times 5 to the 1, which is 5. The value of this 4 is 4 times 5 squared. The value of this 6 is 6 times 5 cubed. You're converting it to base 10, and then add up all those values. All right? Add up all those values. If you have a number and you want to convert it to base 5, for example, let's say I have the number 381, and I want to convert that to base 5. This is base 10, and I want to convert it to base 5. I want to see how the base 5 place values add up to make this, starting from the largest possible value. So I have to write down the place values for 5 first, which is 5 to the 0, 5 to the 1, 5 squared, 5 cubed, 5 to the 4th power. Those will be the place values. And you can only use these numbers up to 4 times. When you're working in base 5, the digits you're allowed is 0 to 5. If you're working in base 4, the digits you're allowed is 0 to 3. The digits you're allowed is always 1 less than the base. So since this is now base 5, the digits allowed on these values is only 0 to 4. You can use these values 0 to 4 times. There's no 5 digit in base 5. Just as well, there's no 10 digit in base 10. 10 is a combination of 1 and 0 working in base 10. So the only digits that exist in our normal decimal system, base 10, is the digits 0 to 9. 0 to 9 are the only digits we see in the base 10 system. 1 less than the base number. All right? So what would be these base values if we convert it? I was doing this as an example. What are the actual values of these base values in base 5? 5 to the 0 is 1. 5 to the 1 is 5. 5 squared is 25. 25 times 5 again, 5 cubed is 125. 5 to the 4th power is how much? Multiply by 5 again, 625. 125 times 5, 625. You're trying to use these numbers to make up this 381. That's in base 10. Remember, you can use each of those place values only 4 times, 0 to 4. You want to see how many multiples of it you're using. So this one out of it, because the number that you're trying to make up is less than the 625. So you're not going to use the 625. So this place value is not going to be used at all. So the next place value that you can use is the 125. How many 125s are in this 381? 2 of it or 3 of it? You can check it out. 3 times 125 is 375. Yes, so 3 of this. You can actually use 3 of this. You can't use 4 of it. So I'm going to put a 4 to say that we're going to be using this. Not 4, 3 of it, let's say. 3. We're going to use in 3 of the 125. So it's like you take 3 of the 125 out of that. So this number, how much you have left to use? So you have 385. You have already used 3 of the 125, which is 375. So I've used 375 out of it. So you subtract so much you have left. So out of that, we have 6 left. Only 6 left. Only 6 we have left. Maybe try to use a different number. Let me change the number. Let me use a bigger number. Let me use 394. So I have a bigger number left. All right. Let me just use 394. So 394. So we still use the 125 oh, sorry. 394 subtracted. So it becomes 394 minus 375. 394 minus 375. I have 19 left. What I can use? 19 left to use to make up this 394. So I look now, can I use any of the 25s? No, because 19 is less than 25. So I'm putting a 0 here. I'm not going to use any of the 25. So can I use the 5? How many of the 5s can I use? I can use 3 of the 5s. I can use 3 of the 5s out of this 19. I'm going to use 3 of the 5 for 3 years. So I'm going 15 more. 3, 5 are 15. So subtract you have 4 left. So you want to know how many of the ones they can use now out of to make up the 4. 4. You're allowed to use 4. So you put 4 right there. So that's how you make up that number. Right? So it means that this number to base 10 is this number to base 5. That's what it means. So you can write the answer now. So you would say 394 to base 10 is equal to 3034 to base 5. And that's it. So you see, use the place values to go either way. You go from a number to base 10, use the place values. From a base to a decimal number, still use the place values. When you have a decimal number, you're seeing how much of the place values you are using up to make up the total number. And when you have a base number now, you just put them in the respective place, and you're seeing like this one here. This is base 4. If I wanted to know what this number was in base 10, I would say, okay, it is 1 times 4 to the 0, 0 times 4 to the 1, 2 times 4 squared, and 3 times 4 cubed if I wanted the entire number and add up all of those. But in this example, I only wanted to know the value of the 3. The value of the 3 is 3 times 4 cubed. Because the 3 is in the place value of 4 cubed. Because this number is in base 4. So base 4 starts from 4 to the 0, then 4 to the 1, then 4 squared, and so on. Those are your place values. All right, guys, let's move on. Don't want to spend too much time on this one question. All right, so I'm just showing you that. This is the example down here. So like a revision of bases. Base don't come an example. In fact, I think this is the second time in recent time I remember a base come on the exam paper. Second time. All right. Don't come on every exam paper. But this one is a nice one. And you see that. But understand it. You need to go. If you never get it, go and work it over back. Do it again by yourself. All right? Good. Then we have this question here now. Let me make this small and shift it up because make this a little small and shift it up. Don't want to move that. It's small. All right. We'll come to this question now. So this was part 2. Come to part B now, right here. What does part B say? Part B says, by writing each of the numbers in this fraction to one significant figure, find an integer estimate of this value. So we need to write each of these numbers to one significant figure. So the one significant figure is going to be the first non-zero value from left to right. All right, so this is going to become equal. Can literally just put it right here. So this stays 600, because the first significant figure is 6, so that stays 600. Minus, first significant figure is this, 8. And the 8 is going to be increased by 1 because of that 7. The size of the number cannot reduce. This number is in the tens because it's an 80th number. So it can become a 90th number. It can't become 8. 87 can't become 8. So it must make sense. So when it can't become 9, 87 cannot become 9. There's no way 87 can be estimated to 9. It can be estimated to 90. So it have to make sense as well. So anybody put 9, that don't make no sense. All right? The size of the number must be, so the number is in the tens, the estimation is in the tens. The number is in the hundreds, estimation is in the hundred. The number is in the thousand, the estimation is in the thousand, something like that. The number is in the ones, the estimation is still in the ones. Can't have a number in the ones and estimate to be in the tens, like far up in the tens. That makes no sense. You understand? So this number, so basically when you use a 7 and increase this, right, you're going to replace this number, this 7 now with a 0. And so you're going to become a 90. So this number, one significant figure, is going to become a 90. But understand that. And we're dividing that now. This number in here, again, we're going to change this decimal place. That's going to become a 30. Because the 9 is going to increase this 2 to a 3. And they replace that with a 0. It's going to become a 30. That's what it becomes. And they wrote that out now. So it becomes fraction. I have to show that working out because they tell you what to do. So it becomes 600 minus 90 over 30. That works out to 27. So that's equal to 27. That is it. But okay with that? It's right across here. So that's what it becomes, 27. All right? So you see you're getting an integer for your answer. You can't put no 20, you can't work that and put no 27 point nothing, nothing. You want an integer answer, 27. All right. Next question. Integer, remember, integer is a whole number, positive or negative whole number. Our next question said, Alana and Brent, whatever that is, shared this amount of money in the ratio 8 to 17. What up? What up? Huh? 17? Oh, I put somewhere on the calculator. I put 900. My mistake. I put 900 in the calculator. So it takes so long to talk. I put 900 in the calculator. So it's actually 17 for 2. See? Same thing. I have to check where I put in the calculator. See? I put 900 in the calculator. That's why. So 6. All right, good. Get 17. On the bright enough. So on the bright. 17. All right, good. All right, let's go. This one says no, they are sharing this amount of money in the ratio 8 to 7. The 8 to 7 has 15 parts, don't it? 15 parts. One getting 8 out of the 15 and one getting 7 out of the 15 parts. Show that Alana received this amount of money. Alana get the 8 part, don't it? So Alana receives, let's put it right here. So 8 out of the 15, let's put it right here. So times the amount of money of 9280. And that's supposed to, not 9280, 17 something. Come on, Mr. Shaw, focus. 17,400. And that's supposed to give it a figure, right? 8 over 15 times 17,400. Good, I'll get the same figure that I said, right? That is equal to 9280. So shown, right? That is it, shown. Shown. Shall lift up those lines of the paper. Next part now says, Alana invests her share of money into a business venture earning simple interest at a rate of 4% per annum. She received $2,088 in interest. Determine the number of years she invested the money. So we're going to be using the formula I equals PRT divided by 100. And in this question, we're trying to find the time, guys. We're trying to find the time. So to find the time, we can multiply by 100 and divide on the PR. So you will end up getting 100I divided by the principal and the rate equals the time. So put the values in this and we're good to go. So based on this question, let's write them out. The rate is 4.5, so the R is 4.5. The interest is 2088. The I is 2088. And the principal was this amount up here that you invested. The principal is the amount you invested, the 9280 share. So those are the figures I put into this calculation. Let's do it over here. So So therefore, the t becomes equal to the 100 times the interest, and interest is 2088 divided by the principal, which was 9280, times the rate, which is 4.5. Put that in the calculator and we get the time. And we get the time, we put years on the word on it. And we put the word years there on the time. So the fraction 100 times 2088 divided by 9280, and under there is also the 4.5. 5 years. 5 years. If you leave out the word years, they might lose a mark. 5 years. It's time in years. They said how long? Did they say how many years? Yeah, they said how many years? Number of years. So the number is 5. In this example, let's put the 5. You have to put the 5. Remember, put the year. They did say number of years. Number of years is 5. All right, that's it. Very good at that. Very good. All right, so we'll finish that question. Now come to this one down here now. This one says we have to factorize this expression. That's the difference of 2 squares right there. But this is the same as 1 squared minus t squared. All right? Everybody must remember 1 is a perfect square. The first square number is 1. So this actually becomes 1 minus t times 1 plus t. That's the answer. 1 minus t times 1 plus t, because the 1 is the same as 1 squared. This one is the same as 1 squared. But after that, good. Then we have this thing now. They want us to expand and simplify this expression. Expand and simplify that expression. See if we can fix it over here. Expand and simplify that expression. All right, let me write it out. So we have 5r minus 5q times 3r plus q plus 3qr. All right. Huh? Oh, the first one is 4. Thanks. All right. So we're going to multiply it like this. So for this one, I'm going to multiply this times this, and that times that, this times this, and that times that, right? And so expand this bracket. So each thing gets multiplied. All right. So careful now. So the 4r times the 3r is 12r squared, right? Then the 4r times the q is 4qr. You also put them in alphabetical order. Put the letters in alphabetical order. So we're going to get 4qr. So if the r is r times q, you put qr, alphabetical order. When you put rq, is still right? Then one have the minus 5 times the minus 5q times the 3r going to become minus 15qr. Then the minus 5 times the q squared times the q becomes negative 5q squared. And then add back this 3qr. So we're going to add back this 3qr right here. Very good. They add up all the like terms now. So let's look at the like terms. So this is the only square term there. So that stays 12r squared. Then the qr terms now. This one, and that one are the qr terms. So that's negative 15 plus 7. What's that become? Negative 8. That's negative 8 qr. And then this is the only square term there, so now, which is minus 5q squared. And that is it. 12r squared minus 8qr minus 5q squared. That is the answer for that one. All right? That is it. Make this small. All right. Then we have this thing to solve now. This thing. That's an inequality. So it's a simple linear inequality. The key thing to remember about this, guys, is that if there comes a point we have to multiply or divide with a negative number, we have to reverse the inequality sign. That's a key thing to remember about solving this. But it's basically the same steps as if we were solving an equation like that. The only thing with the inequality to remember is that if you're multiplying or dividing by a negative number, the inequality sign must be reversed. All right, so let's do it right here. So it's negative 4p plus 3 greater than or equal to 19 plus 2p. I'm basically trying to make p the subject. So you can decide to group the p's on the right side, or you can decide to group them on the left side, your choice. Let's say we're grouping them on the left side. So we're taking this and bringing it to over here. Then it will be minus 4p minus 2p, because this comes over become a minus 2p. This stays greater than because we did not multiply or divide. This stays 19. Then this 3 goes over and subtracts and becomes minus 3. This becomes negative 6p greater than or equal to 16. Everybody say that. You're going to divide now by the negative 6 and reverse the inequality sign. Divide by negative 6. But because we're dividing with a negative number now, we have to reverse that greater than or equal to sign. That's what we have to remember to do. So we divide this side by the negative 6, it becomes p. This sign is reversed to a less than or equal to. This becomes now negative 16 over 6. Negative 16 over 6. Numerator, negative 8 over 3. 2 2/3. So good. It's p less than or equal to negative 2 2/3. Negative 2 2/3. Huh? If you left as we short, 8 over 3. Yeah, man. Negative 2 2/3. All right? And just to show you, if we did it the other way, just to show you, let me make this smaller and see what would happen if we did it the other way. All right? If we group on the right side instead, let's zoom up here. So if we had the same 4p, negative 4p plus 3 greater than or equal to 19 plus 2p, I would decide to group the p's on the right side and group the values, the numbers on the left side. Then this would go over become the plus 4p. This will stay over here as a 3. This 90 will come over and become a negative 19. The sign will stay greater than or equal to. You have this 2p on the right side. Then this negative 4p will go over and become a positive 4p over here. Then over here will become a 6p. And over here will become a negative 16. Then again, you have to divide by 6 now. So now, for this one, we divide by 6. That is this 6. But now, because we're dividing with a positive number, we're not reversing the sign now. So then we would get, on this side, the negative 2 2/3 again, but the same 16 over 6. The sign would be now this way, and you have a p. So it will be that this number now is greater than the p, but you can read it the other way. Reading it from right to left, it means that the p is now less than or equal to that. So come back to the same thing. So we could say, i.e., that is, the p is less than or equal to negative 2 2/3. That is it. How to go to that? Good. So either way, you're good to go. Next part now says, determine the largest integer. Integer is a whole number. Value of p that satisfies this inequality. Now, the best way to do that is to show the solution on a number line and see what the first integer is going to be within the range that I give you. So if we're to show this inequality on a number line right now, let me draw it down here. For to show this inequality on a number line, let me put a number line here. So. And this is a p-axis. And we're working in the negative range. So let's say we put 0 here. So -1, -2, -3, -4. The critical value is -2 2/3. That's where the inequality starts. -2 2/3. The -2 here, so The -2 and 2/3 is close to the -3. We're not quite with the -3, so we're about right here, so. -2 and 2/3. That's where you have to put your circle. And you have to shade it because it's included in this one. And then you'll be pointing to the left. They want for the less than it. But if it has to be an integer, then the integers would be these values, the -3 and the -4, then -5, then -6, and so on. If they were integers. And so the largest one would be this, don't it? That would be the largest integer. Other than negative number, the largest of these negative numbers is the one closer to the right. All right? Or the one on the right. And that would be the largest one. So the largest integer would be -3. What is that? -3. So you put -2, no. The best way to show it is to put the number line so you can actually see what is happening. But I go to that. Good? So that would be -3. So this answer up here will be -3. -3. And the solution for this was what again? E less than or equal to -2/3. This answer is P less than or equal to -2 and 2/3. And this up here was factor this one into what? Wipe it off already. Became this. We can copy this right here. This paper kind of messed up. This should be the answer for this one right here. So. All right, I just kind of putting them on the paper. All right, then we have this question down here. So now, can we ever do this one in this area? It gives us this triangle. It is a right angle triangle. And once it is a right angle triangle, you know, you can use so-called tower, Pythagoras theorem. It says, for the right angle triangle, we have to show this. That becomes the relationship between those sides. Sides are in terms of x, that becomes the relationship. It is Pythagoras theorem we're going to use to get this expression. Right? So what do we know about this triangle? We know that this side squared is equal to this side squared plus this side squared. Pythagoras theorem. So that's how you start. Let me do it right here. So. That's what we know. We know that 2x hence. We know that 2x plus 3 r squared, that's hypotenuse squared, equals the side over here, so squared, which is x squared, plus this side squared, which is 12 squared. That's what we know from Pythagoras' theorem. You're going to expand and simplify to get this expression. That's what's going to happen. Right? Now remember, when you expand this perfect square, you're going to get 3 terms. First term squared is 4x squared. The middle term is twice the product of a 2. What is the twice product of a 2? You multiply these two things first. That's 2x times 3, you get 6x. And then double the 6x to 12x. So the middle term is 12x. And the second term squared is 3 squared is 9. That's what the left side becomes. X squared plus 12 squared. And the 12 squared, we can put 144 now. 144. Just need to take this and transfer over here. So we take this x squared and bring it over here and subtract from the 4x squared, you're going to get 3x squared. This is the only x term in it, so it stays there at 12x. Carry 144 and subtract from the 9, how much you get? 9 minus 144 is subtract. What's that work out to? 135. So that becomes -135 equals 0. What understand that? Huh? Huh?
Yes, sir.
We do that? So exam on Tuesday, ask me where the 12x come from today. Go through this so much 1 million times already. When you expand a perfect square, you're going to get 3 terms. And it's the last time now, exam is Tuesday. When you expand a perfect square, you get 3 terms. First term squared, twice the product of a 2. The 12x is twice the product of a 2. Pay attention and stop writing. I'm telling you all the time. Get it in the head before you put it in the book. Go through this multiple times already. Exam is Tuesday. When you expand a perfect square, it becomes the first term squared twice the product of the two. The middle term is what people always forget this one. Or you get it. Twice the product of the two means that you multiply the two things them first. You're going to get 6x and then you double it. That's how I get the 12x. That's twice the product of the two. Teacher, generally speaking, look, a plus b squared really means a plus b times a plus b. If you expand this out, you're going to become a squared plus 2ab plus b squared. If you expand it out by doing this, look, if you expand it out by doing this time this time that, this time this, this time that. You're going to get 2ab in it. You're going to get ab plus ab. 2ab's you're going to get. You're not seeing it. Do this all already, you know. Teachers are like the same thing more than one time, you know, especially when you spend a lot of time on it. More than once. So if you expand out this step by step, you're going to get a times a plus a squared. You're going to get a times b is ab. See, you know, you're going to get b times a is ba. That's another ab. See, it's two of them there, two ab's. They're going to get b times b squared. So it becomes a squared plus 2ab's plus b squared. For some reason, people don't forget about that value right in the middle there, so. Twice the product of the two numbers. See there, the two numbers in the bracket is a and b. The product of them is ab. And they double it to 2ab. If this was a minus inside here, so, then this will become a minus in the answer out here, so. This will become a minus. It's not complicated, guys. You have to remember the way you expand a perfect square, you get 3 terms. Something, look here. So I'm telling you, if you make a mistake on something, guys, you have to remember it. So if you expand on 2, if you expand a perfect square like this one day, and you only write 4x squared plus 9, and then come class and discover self, you have to do the 3 terms, you know. Oh, you're going to forget it again, ever and ever, amen. You must remember that you made the mistake. I say, every time you expand a perfect square, it's 3 terms you must get. You have to remember. It's not just the first term squared and the second term squared. This is wrong. I don't expect people to be making that mistake at this stage. We'll go through this multiple times, and I have to remember the key critical things, especially when you make the mistake before with it. And that's why I'm always say, redo the question. Don't just look back at it and say, you have correct it. You don't lodge in the brain that way. You have to literally redo it. Do it again. The right way. Make it go in your brain the right way. Because the wrong way is still in your head if you don't do it the right way. And that's why we keep repeating the same mistakes. You have done this already multiple times. I think you do have in papers we do recently, we've encountered the same situation. I would do it. I didn't expect nobody to ask me that today. God no, I'm not lie to you. Anyway, so you may see the catch it. Once you catch it before the exam, everything good. So you know when divide 2 by 3, right? Because it's this we're trying to get to know this. And you can see it. We divide this by 3. Because all the values in this can be divided by 3. So divide this by 3 becomes x squared. Divide this other one by 3 becomes 4x. Divide the 135 by 3 becomes 45 equals 0. So that has been shown. That is it. But all right? Okay, good. I need to do this paper clean. All right, next question down here. All right, so there's another question people have questions about here. This question about some rotational symmetry. People asking me to do the test. For rotational symmetry. The question says, this is a regular octagon. And the question takes you like regular shapes, regular polygon. Yesterday we do a regular hexagon. Concept is the same. The question is asking us, Part one. How many lines of symmetry does it have? And what is the rotational order? Right? What is the rotational order number? All right. The lines of symmetry, everybody know lines of symmetry, right? The line that divides it half and half, one half is the mirror image of the next half. Right? So I have to basically just count them out. Just count them out. So the first lines of symmetry, you have one down here, so let's do the halfway sides first. You have one across here, so let's count them this way first. One down here, so one up here, so one across here, so one down here, so. Then there's another set of symmetry through the intersections. That's four so far, right? So I have come across the B and the thing there, so that again is a line of symmetry. See, it cut the half here and the half here, mirror image. Right? And then you can cut another one like this. Let's try it better, Mr. Shaw. See that? And then you can cut another one like this. And then you cut another one like this. So 4 blue lines and 4 red lines. 4 blue lines of symmetry and 4 red lines of symmetry. So the total lines of symmetry here is 8. And a lot of people put 4 in it, you know. 8. Put 4 here wrong. Let them get half of the mark. You know, wrong. Let's talk about rotational symmetry now. So I show the 4 lines of symmetry. Let's talk about rotational symmetry now. So let me just copy this thing. Oh no. Copy this. Show the lines of symmetry. Paste the cursor. All right, so those are the lines of symmetry, right? Let me clear this now and show you the rotational thing. Let me show you the rotational thing by copy this same object again. Show you. So I'm put a red line up here as a reference line. I'm put a red line up here as a reference line. So I want to explain rotational symmetry now, right? So I'm putting a red line up here as a reference for you. I'm going to copy this thing and show you the thing I rotate. Let me copy this for you. I just want to run this out. So, copy, paste. Watch this now. I'm going to use this to explain rotational symmetry to you. Pay attention, everybody. You only need to see it explained one time. So rotational symmetry are the order of rotational symmetry. It's basically like this. The number of positions where the shape is exactly the same as you rotate the object through 360 degrees about its center point. So like you're taking this octagon and you're rotating it about the center point here, so. You're rotating it about the center point. I want to see how many positions it will look exactly the same as it is now. So where we're starting now, that's called one position. So I'm going to make sure I put the red on top so you can see it as a reference. And I'm going to rotate it so you can see how many positions it look the same. And you know what? Let me put a line down here so we can use this line as a reference line as well. So I'm going to put a line down here on the base. So every time the flat side, every time one of the edges or one of the sides become flat, it's going to look the same. All right? And the red is going to allow us to count how many positions we have. So we can understand it. So I'm now going to rotate this. All right? So that's 1. We started 1. You count the first position as 1. I don't repeat any position. So the red is at the top, that's position number 1. That's order 1 so far. So every object have a rotational symmetry of at least order 1. So this is one position how it look, right? Good. So watch it now. Rotate this. So one position look exactly the same as it did before. That's 2. Don't? Let's rotate it again. Rotate again. That's a third position. Look exactly as it was before. But it's not the same enough. Because the red now reach back where it was then, right? That's 3. Let's rotate it again. That's 4. Don't it? Let's rotate it again. That's 5. Let's rotate it again. That's 6. Let's rotate it again. That's 7. Let's rotate it again. That's 8. That's 8 we're gone. If we rotate one more time, it will reach back where it was, so you can't count that. So the order of rotation and symmetry of this object is 8. Generally speaking, regular hexagons, the number of sides match the rotational, the order of rotational symmetry. So like, for example, an equilateral triangle where all the sides are the same, because that's a regular polygon as well. Rotational symmetry of order 3. I can rotate into 3 positions and it will look exactly the same. Hexagon going to be 6. You get me? Just like this. So the regular polygons, same order as the number of sides. Alright? So this rotation symmetry. You understand rotation symmetry now? So whichever shape them give you can check it. So it may give you any shape I give you, you can basically check it. Alright? Which shape I can maybe try with it. So if I try a square, rotation symmetry of a square is not much. Huh? Square. Rotation symmetry of a square. Rotation just in a while ago. So regular polygon, them are the same number of sides, so it's 4. Just in a while ago, a square is a regular polygon with 4 sides. Listen to the details. So rotation symmetry of this one is 4. 4 different positions it can rotate and look exactly the same. See, then we put the red side up here again. That is 1. Next to the red side gonna be here. That's 2. Next to the red side gonna be here. That's 3. Next to the red side gonna be here. That's 4. See that? So the regular one's easy. All right, let's tell me a circle. Rotation symmetry of order of a circle is what? Infinite. That infinite number of positions you can put a circle, rotate it, and it will look exactly the same. So that's infinity. The shape we can try. Somebody tell me a shape. What kind of triangle? Yeah, that's a triangle. So what kind of triangle? And let's say we try an isosceles triangle. Like this. Let's make it better. Like this. What's that one? What that one look pretty? Remember you're rotating it, rotate about yourself, for example, about the center point. If I take it and I rotate it, guys, it will never look the same again. Right? Oh, sorry. Remember, you're not flipping it, you're only rotating it. You are rotating it. So if I have this, I rotate it. The only time it will look exactly the same is when it reach back the original position. So the order is 1, you see? See that? Let me set it like this. Make it more obvious. Watch. Make it more obvious. Let's draw it like this. Remember, it's about rotation. Think of as if you're rotating this thing. So it's the order 1 right? Order 1 right now. So if you turn it, it will never look as the original one. Hold on, come again. It will never look like the original one if you rotate it. It will never look like the original triangle. Never. Never look like the original triangle until you reach back the original triangle. You can't put the same position 2 times. You see that? So this was up order 1. That's an isosceles triangle. But I get that. What about this one? I'll give you another shape. Suppose I give you what we call an isosceles trapezium. So like an isosceles plus trapezium look like so. isosceles trapezium. So that's top side here. You have a side come down, so side that look exactly the same like that one, but set it up on the next again like this. And you have the line across here, so you know, so perfect, but you get the picture. So what happens is that it's supposed to have a line of symmetry down the middle, so that's what I'm trying to draw. But this thing can draw it for me. Yeah, let's try it for me. So we have this isosceles trapezium, right? And I'm going to rotate it. So I take it and I rotate it like that, right? Will it ever look like itself again? No, 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 no. The other one. See that? Other one. Equilateral triangle is order 3. You take this and you rotate it. It look like itself there. So again, that's 2, that's 3. And you put one on the side in a color so you can see it. Put the side in a red so you can see it better. And rotate it. That's 1. That's 2. That's 3. 3 places exactly the same as they did before. That's order 3. But basically that's rotation and symmetry and nutshell, guys. All right. So the order is 8. 8. Think you understand it? Good. So remember, I must have that order of at least 1. First position is 1. If you have so many times, if you rotate it 360 degrees about the center point, it will look the same again. How many times it will look the same? All right, let's go. And this one wants us to calculate angle G. Let me tell you something. Whenever you get a polygon to work in a calculation, it is a lot of the time it is easier to work with external angle or the exterior angle because you know the total exterior angle is always 360 degrees. Total interior angle change, depending on the size, depending on the number of sides, But regardless of the number of sides, the exterior angle exterior angles will always add up to 360 degrees. So a lot of the time, that calculation is easier to work with. So to find an interior angle, sometimes better to find the exterior angle first and then subtract from 180. Because the exterior and the interior must add up to 180. Let me show you again. I did this with the hexagon yesterday. All right? There are 2 ways to do it. You can work from the perspective of the interior or the exterior. Exterior easier. So to find that angle G, what I'm going to do is find this exterior first. Find this angle out here first. Let's call it theta. That's an exterior angle. And it's a regular polygon. Regular polygon. So it means that all the exterior angles are equal. And all the interior angles are equal. And if it has 8 sides, it has 8 of them exterior angles and 8 of them interior angles. 8 of them. The 8 exterior angle, the 8 of these exterior angles. So let me so you have 1 more right there, so. 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 And you have 1 more right there, so. 8 of them. Those are the 8. If you have 8 sides, that's 8 of everything. 8 sides, 8 angles, 8 vertices, 8 interior angles, 8 exterior angles. And because it's regular, all of them equal, everything equal. All the sides are equal in length, all angles are equal. So you have 8 of these angles, making up 360 degrees. But the exterior angles will always add up to 360 degrees, regardless of the number of sides. If you something have 1 million sides, the total exterior angle is 360 degrees. If it has 3 sides like a triangle, the total exterior angle is still 360 degrees. Yes. The total interior angle of a triangle is 180, but the total exterior angle of a triangle is 360. So therefore, this diagram, using the concept of the exterior angle, Total exterior is 360 degrees. And there are 8 of them. I'm calling each of them theta. So 8 times theta, or one of them then becomes 360 divided by 8, don't it? So theta then becomes 360 degrees divided by 8, because there are 8 of them, making up a 360. What is work out to? 45 degrees. Therefore, the G is simply 180 degrees minus 45 degrees, which is 135 degrees. Easy like that. Working from exterior angle. But you can also work from interior angle. I know. N minus 2 triangles. A polygon, yeah, that's what we say with triangles. N minus 2 times 180, because we say a polygon can be divided into N minus 2 triangles. Right? So this polygon can be divided into 6 triangles. See here, these 6 triangles here, look. If you draw a line from here, so to here, so one here, so that's 1 triangle, 2 triangles, 3 triangles, 4 triangles. Well, actually 6 triangles. 1, 2, 3, 4, 5, 6. So the polygon, because that's 8 sides, can be divided up into 8 minus 2, 6 triangles. And each triangle has 180 degrees in it. That's why the total interior angle is N minus 2 times 180. N minus 2 times 180. Each of the triangles is 180 degrees. So if you use an interior angle to do it, you would say, all right, the G becomes equal to total interior angle, which is N minus 2 triangles divided by 8. All equal, don't it? So it will be N minus 2 times 180 degrees. That's the total interior angle, don't it? Divided by 8. So you could get it that way as well. So it will become G equals 8 minus 2 times 180 degrees, and there are 8 of them divided by 8. That's going to give you the same 135 degrees. Because 6 times 180 divided by 8. Let's make sure. 6 times 180 divided by 8. See the 135. They could do it from the perspective of interior angle as well. I say you have 2 choices, your choice. You decide what you want to do. And let me use both of them. Make this one small. Make this one smaller too. So for this one, we are saying total interior angle. Total interior is N minus 2 triangles. N minus 2 times 180 degrees. That's what we use. Because all of them equally divided by 8 to get one of them. That's it. So this equals that, right? 135 degrees by those calculations. Very good. Our next question says, spend a lot of time on that though. G equals 135. I don't need to know. It says, the diagram below shows 2 similar triangles. Once you see similar triangles, if you remember, the ratio of corresponding sides are equal. And the ratio of the square of the area is equal. The ratio of the area is equal to the ratio of the square of corresponding sides. So the ratio of the sides, corresponding sides are equal on the 2 similar triangles. And the ratio of the areas of the 2 similar triangles equal the ratio of the square of corresponding sides. Let's see what they want us to do. So this triangle now, there are 2 similar triangles. What are the similar? You have to identify the similar triangles to you know. So this small one and this big one out here, so similar. See that? Small one and the big one. And I said to you, anytime you have a big triangle and there's a side in a line in it that is parallel to one of the outer sides, you form similar triangles by doing that. All right? Similar triangles. So I have 2 similar triangles here. And it give us some dimensions. So these two lines are parallel, yes? And it give us that some dimension. This side is 5, and this side is, all right. I'll send the solution afterwards. This side is 7, and this side is 21. So these two sides correspond to one another. See that? Those are corresponding sides, right? And the corresponding side horizontally is this piece here, so, with the whole of this outer, so. Those are the corresponding sides. So the reds are the corresponding heights, and the purples are the corresponding bases. You see that? But I can't say that. All right? So they want us to calculate the length of yx. That is right here, so. Yx. Now watch this now. You see this? You see this base on the big one? The base on the big one out here, so. Is really 5 plus this length where them want, the yx. See that? 5 plus yx. All right? So we're going to use ratio of corresponding sides are equal like this. The ratio of corresponding sides are equal. Watch this now, tell me if you see it. So I'm going to use base on the small one, base on the big one over base on the big one over height of the big one. Let's go again. Base over height on the big one equals base over height on the small one. You can say that? So base over height equal base over height. You can do it that way. Ratio of corresponding sides equal. So base over height on the small one, base over height on the big one equal base over height on the small one. You can set up the ratio any way you want. So I'm going to use 5 plus yx. That's the base on the big one over the height of the big one, which is 28. Equal that base over height, right? Equal base over height on the small one. The base on the small one is 5, and height on the small one is 7. But understand that? So we're using base over height as a ratio. See there, base over height. Base over height. So base over height on the big, this is on the big, equal base over height on the small. But understand that? I could have used height over base if you want, but I feel like I like when the unknown that I'm trying to find is on the top of my fraction. That's how I started away. Because transposition is easier. So we're transposing to find the yx now. So we're going to take the 28, multiply it up here. First, I'm gonna get 5 plus yx equals 5 over 7 times 28. We'll take the 5 and I'll subtract it. Take the 5 and subtract, you're gonna get yx equals 5 over 7 times 28. I'm gonna subtract 5. What I work out to? Now this is 4. 4 5 is 20. 20 minus 5 are 15. So 15. So yx is 15. That's the answer. But I go to that. Simple as that. Yeah? And then now, I want us to determine angle VWX. That's angle up here, so the one. Yeah? Huh? What you say? We could use any, we can set up a ratio any way we want. Just remember the ratio of corresponding sides equal. So when you set up the ratio on one side, you have to set the ratio on the other side the same way. So let's use base over height for this example. So base over height on the big one equal base over height on the small one. Good? Simple. All right, so we want to find this angle now. Let's call it angle theta and shoot on the diagram. It's angle up here, so. The more, theta. So to find that one now, we're going to use the side, and the side I work out to be 20, don't it? I'll just work out that this is 15, also. Just work out that this side is 15 centimeters. So it means that the whole is at 20, right? And it's at 28. So we're going to use tan, and that's what we know. In the big triangle now, we know the opposite and the adjacent. So we're going to use tan. That's what we're going to use, tan. So down here, we're just going to say tan theta, calling the angle theta, equal the opposite side of 20 over the adjacent side of 28. The theta then is tan to the minus 1 of that. Tan to the minus 1 of 20 over 28. And you put that in the calculator and work it out. So it's tan to the minus 1 of fraction opposite over adjacent. That's 35.5 degrees. Remember, so we said you must give the answer to one decimal place when you're giving angle in degrees. 35.5 degrees. That is it. But okay with that? But the word? All right, beautiful. Let's go. Next question. This question is a coordinate geometry, but they don't give us any graph distance, so calculate. So have to remember our formula them guys. For coordinate geometry, right? Our method. So they give us this straight line, and they say it passed through this point. If it passes through that point, it means that these coordinates can work in the equation. That's what it means. The coordinates of the points satisfy the equation. And I want us to show that the value of C is 10. So in other words, when I put this X value in there, we can put these values in there. Put that one for the X and put the 8 for the Y. That's what we're gonna do. And work it out to get the 10, right? Simple as that. So it's gonna become 3 times negative 2 plus 2 times 8 equals C. Equals C. The point is on the line, so it satisfies the equation of the line. You can substitute the coordinates of the point into the equation of the line. And whatever you get will be true. All right? So this works out to be 16 minus 6, don't it? That's a 10, that's all? C equals 10 for true. So C equals 10. Very good? Simple as that. All right, I'm changing the color of these two lines so one can see them separate. So we'll put the negative 2 for the X and put the 8 for the Y right here. So that's what we did. Substitute them. All right. So the point is on the line, so it satisfies equation line. Then we want the gradient of the line n. So to get the gradient, we're going to put it in the form y equals mx plus c. Like y the subject. That's what we're going to do. Put it in the form y equals mx plus c. All right. So the equation now becomes it becomes 3x plus 2y equals 10. Over this first, we're going to get 2y equals minus 3x plus 10. Remember, we're trying to get this, y equals mx plus c. We want equation to look like that. Not this c, This c, our normal c. Don't confuse them. Not the same c. Then now, to make y alone the subject, we need to divide by this 2. We divide by 2, we divide each value by 2. So I divide 2 by 2, or we'll say multiply 2 by a half. Whichever you want to look at it. So divide it by 2, you're going to get y equal, divide this by 2, it becomes negative 3 over 2 times x. Why I do it like that? Because I want to be able to isolate the m and see the m separately from the x. And then divide this 10 by 2, you get 5. So y-axis intercept is 5. So the gradient is negative 3 over 2 right there. So see there? So the gradient m is minus 3 over 2. Why do I go to that? It says, the line this, that's another line, intersects L at the point T. Determine the coordinates of T. To do that, we solve the two equations simultaneously. To find the point of intersection, we solve the two equations simultaneously. That's all we have to do. So the equation we're solving simultaneously are 3x plus 2y equals 10. That's the first one. And this one, no. 3x plus 4y equals 8. And 9, they give us it with two values the same. So we can subtract to eliminate the x. We're going to subtract them. So subtract these two equations. Subtract. So subtracting, let's subtract it this way. Let's subtract the bottom one minus the top one. Why am I doing that? Because the y value is greater than the y value there. Let's subtract them that way. The bottom equation minus the top equation. So the bottom equation minus the top equation, the 3x minus 3x, x gone, right? 4y minus 2y is 2y. So I'm getting a 2y over here. Equals 8 minus 10 is negative 2. This means that the y is equal to negative 1. But I can say that. But I say that, I divide by the 2. Now that the y is -1, you can plug it back in any one of the 2 equations you want. Let's put the y equals -1 let's put it in the top one. 3x plus 2y equals 10. Put it in there. Put the y equals -2 there, so. -1 there, so we're going to get 3x plus 2 times -1 equals 10. This 2 times -1 is a -2. -2 come over and add to the 10, give me 12. So I'm going to get 3x equals 12. Let me divide by the 3. We're going to get x equals 4. And therefore, t is the point what? T is the point. This x value, put x value in the bracket first. So if you work on the y value first, put it in the bracket second. So the point t, same say the point t, and put it right here. So t is the point, 4 is the x value, -1 is the y value. That is it. But okay with that? Very good. All right. Next part down here, so now. It says the diagram below shows a graph of line L. So they give us the line L here. So this is the line L they gave us. This line. All right, that first line is L. See the y-axis intercept is 5 for true. It's really 5, right? And they give us 2 other lines. X equals -1, that's this line. X equals -1 on vertical line to -1. And y equals 5. Y equals 5, all right? Question says, on the graph, draw the line y equals x minus 1 first. Draw this line first. Y equals x minus 1. So we can draw the line quick and fast. We know say the y-axis intercept is -1, don't it? And it has a gradient of 1. See? The number in front there is not shown, so it's a 1, right? So for that line, c is equal to -1 and the gradient is equal to 1. Now 1 means rise 1 over run 1, don't it? Rise 1 over run 1. So we can rise and run from this. We would have to rise 1 and 1 because we can make a bigger rise and a bigger run. So we can maybe put, like, say, what does it go up to? This go up to about 7. So we can go 6 over 6. So we can rise 6 or rise 7 over run 7. 7 over 7 is still 1. But understand that. So we can just do a 1 big rise and 1 big run and get another point on the graph. So we can draw the graph that way. Use the y-axis intercept and then use the gradient to rise and run to other points. So some people prefer calculate coordinates. You can put on the y-axis intercept and then use the gradient to rise and run to get to other points. Since the gradient is equal to 1, 1 is the same as 1 over 1, meaning rise 1, run 1. But we don't have to make that like a small rise. You can instead rise 7, run 7, or rise 5, run 5. Remember also when I'm rising and running on the grids, we're rising and running on the units. So I have to check the scale. So horizontally, 1 grid is 1 unit, good. And vertically, 1 grid is 1 unit. So here we can write the grid. The grid is the unit, is the field. So ready now. So the y-axis intercept is this point right here, so -1, right? That's 1 point on that line. I'm going to make a big rise of 7. So if I rise 7, we'll come up to 6, don't it? But -1, we rise 7, I come up to 6. Up to here, so. And then run 6. If I run 6, I go over to 7. No, sorry, I run 7. So from 0, I run 7, I come across to 7 over here, so. 10 too thin, you're not seeing it. So I rise 7, sorry, I mean 7 over 7. So rise 7, from -1, if you rise 7, you come up to 6. And then from over here, if you run 7, you're going to come over to 7 over here, so. So that's a point on the graph. Rise 6, not 6, I keep saying 6. Rise 7, run 7. So that's another point on the graph. So all I need to do now is draw a straight line through those 2 points. This y-axis intercept on that point. The rise and run gave me that point. So draw a straight line through that point now, like so. That's it. That's my line. Y equals x minus 1. Simple as that. Some people might plot points and get it, but the gradient and a y-axis intercept is a nice quick way to draw one line. Put on a y-axis intercept and then rise and run from it using the gradient. Because the rise gradient is how you rise and run from one point to another point. So that's the line y equals x minus 1. Nice and easy. Then they want us to know, shade the region that satisfies these inequalities. Let's look at them individually. Let's put on what each one means. So this x greater equal to 1 means above, don't it? Above the line x equals -1. Above a vertical line is to the right of the vertical line, don't it? So it means that we want to the right of this vertical line. Let's put our arrow pointing to the right. Next one. This means below. Whatever is positive, the less than means below. So this one means, this down here so means below. We want to go below this line. Below the line y equals 5. This inequality means that we want to go below the line y equals 5. So line y equals 5 is this line. When I put the arrow pointing down, to remember that I want to go below it. So right now, I want to be to the right of this vertical line and below this one, below this horizontal. So it's down as someone wants so far. Some down there some. But let's now write down some more. All right. Then this one now, this line that we just drew a while ago. And since whatever here is positive, it's greater than means above. So I want to go above this line now, above the line y equals x minus 1. That's what this inequality means. So I want to go above that blue line. The blue line is what we draw, the one line that we drew. So I want to go above this line. So I'll put the arrow pointing up. Above that line. I can't put it down. So I want to go above it. So the reason that I want to know is somewhere in here. So watch me now. Somewhere in here, someone wants a fire. See, below this one, above this one, and above the blue line. So far, I would want that triangle. But I have one more inequality to put in. So let's go for it. So far, that's the region that I want. All right, that's the region that I want so far. Let's go for the last one. So this one now, the y over on the left side of the inequality is positive. So this less than means below. So this means below the line 3x plus 2y equals 10. I need to go below this line. And that's the line that we had before. This black line here, so we need to go below it. I'm going to put the arrow pointing down. Let's zoom in on it now. So this region, you know, because look, it is below this horizontal line. It's below this line right here, so. It's to the right of this vertical line right here, so. It is above this blue line. So it's up here, so. It's below this black line that we gave us horizontally. So it's below here, so. So the region that we want is inside the majority in purple for you. It's inside here we want. That region satisfies all the inequalities. Below the one that is supposed to be below, above the one that is supposed to be above. That region satisfies all the inequality. But you can see that. That's the region that you can't put none of it up here, so if you put this part over it, it's wrong. That must not be in it. And you can't put no part of the over here so in it either. Wrong. Can't put no part of that in it. Because if you put any part of this in it, it's going to be showing above that line. It's not supposed to be above it. It's supposed to be below it. But whatever, it must be less than 5. Less than or equal to 5. All right? So basically, that is the region. But I go to that. So that's the region in purple that you would shade for this question. Good? Taking my time on this one. This might be the last one that we do before the exam. So I'm taking my time. And it's the most recent exam. So let's go. Next question. Pie chart. This question says, it says, some grade 2 students were surveyed to determine the job sector in which they are most likely to seek employment after graduating. All of that fluff. It says, their choices are represented in the pie chart below. So we see the pie chart and zooming in on the angles. So we see the angles here. So we have some angles in terms of P. Those 3 are in terms of P. This one is says 90, so you don't show the 90. That one is 90 degrees. Cannot ignore it. That one is 90. Let's put it there. This one is actually 90. A lot of people go ignore it, but this is 90 degrees. That's one of the angles for the healthcare, 90 degrees. All right. And then you have two known angles, 67.5 and 40.5. That's for agriculture and ICT. So we know those three. Healthcare, agriculture, and ICT. We know those three. And the others are given in terms of P. Remember, the total angle around here is 360, guys. 360. Total angle around here is 360, okay? So all those angles must add up to 360 in the pie chart. Anyway, let's see what I want. It says, calculate the percentage of students who are likely to seek employment within the agriculture and ICT sector. So combining the agriculture and ICT sector. But I want it as a percentage. So we can get it as a fraction of the 360 first that the angles are, and then express that as a percentage. All right? So that calculation for this one is going to be the agriculture and ICT total, which is 40.5 plus 67.5 as a fraction that is out of 360. But because I want as a percentage, you multiply that by 100. So this is as a fraction, as a percentage, you multiply by 100. So to get a fraction to become a percentage, is multiply by 100. So basically that's it. So this will be the fraction of them, of the total students. But they want that fraction to be expressed as a percentage. So multiply by 100, all right? So let's do this calculation. And you get it. They want to combine. So it's 40.5 over. Let's go ahead. 40.5 plus 67.5. All right, foolishness. I'm writing foolish. All right, let's go ahead. Fraction. 40.5 plus 67.5. Good. Over 360. That's another fraction. It's 30% then. The thing is 0.3. So it's 30%. Answer is 30%. All right, done. Then I want to tell them the value of P. The value of P. So to get the value of P, you're going to add up all of those angles and total 360, right? 360. The total angle must be 360. Let's do it right here. What the P is add up to? Okay, add up the P's, it's 4P, 3P, and 2P. The P is add up to 9, don't it? P's add up to 9. So it's 9P. All right, let's add up everything, must add up to 360. So we can say the 40.5 plus the 67.5 plus the 90. Those are the angles that we know. Plus the 9P, we say, right? 137 plus 2 meant 9 plus the 9P. That must equal 360. Everything in degrees. So therefore, the P becomes 360 minus these numbers divided by 9. Nobody say that? So the P becomes equal to 360 degrees minus these three add up together, which is 40.5 plus 67.5 plus 90. And you have divided by this 9 now. Divided by 9. All right? And put that in the calculator and see what you get. Let's see. Fraction. 360 minus bracket 40.5 plus 67.5 plus 90 close bracket, dividing that by 9, 18. So P is 18 degrees. Okay, I'm putting degrees on it because they didn't put any degree on the P. So the P therefore is 18 degrees. That is it. P is 18 degrees. But good? 18 degrees. But I got 18 degrees. One bright. Very good. Next question says, Liz has a set of red. Also, this is probability now, guys. You see? They've been setting a lot of probability questions these days. You have to go outside, send it to I already know. So this one says, Liz has a set of red, yellow, and white buttons in a sack. All right, she chose buttons at random. He said the probability that she chooses a yellow is 0.3. Let's write them out. The probability for a yellow button is 0.3. The probability for a white button, is 0.1. He said determine the probability for a red button. Now, remember, the total probability has to be 1, guys. Probability cannot go between 0 and 1. So the total of all the possibilities in the space must be 1. So since the probability of getting a yellow is 0.3, and the probability of getting a white is 0.1, that's 0.4 gone so far. So therefore, since the total probability must be 1, the probability of getting a red must be 0.6. Can do it this way. Understand that? Total probability must total 1. The total of all the probabilities, all the possibility must add up to 1. The one sample space, which is the sample space at the back, the total probability of the red, white, and blue, red, white, and yellow must come to 1. Right? So see the probability of the red must equal the total probability, which is 1, minus the 2 we're going so far. Because the 3 of them must add up to 1. I can do it that way then. Look at it this way. Probability of the red plus the probability of the yellow plus the probability of the white must total 1. See that? And you know these two already. Those two add up to 0.4. So the probability of the red then becomes 1 minus 0.3 and also minus 0.1, which is 0.6. 0.6. So that's a 60% chance. So the answer here is 0.6. Probability of a red is 0.6. But the total probability is 1. All right? Next part now says, if there are 80 marbles, 80 buttons in the sack originally, determine the number of buttons that were red or yellow. Now, generally speaking, or means that you add the probabilities. Right? And you multiply the probability by the total to see what the actuals are. So the probability of a red or a yellow, you're going to add those probabilities. So the red and the yellow combined. See there? The red is 0.6 and the yellow is 0.3. So the probability of the red or yellow is going to become 0.9. You understand that? So it's 0.9 of 80 marbles. Now there were 80 marbles in there. Right? So let's set up like this. Remember now, the probability of the red is 0.6 and the probability of the yellow is 0.3. Combined is the probability of red or yellow. You're going to add them, the probability of the red plus the probability of the yellow, which becomes 0.9. So it's a chance of getting a red or a yellow. Right? But there are 80 marbles total. So therefore, the number of marbles, number of red or yellow, by adding them, combining them, becomes 0.9 times 80. Come in mind, the probability like a percentage, you know. So you could say, okay, this is 90%. So 90% of the 80 marbles is yellow or red. That percentage could have been expressed, probability can also be expressed as a, somebody knocking on the door? Yes. That's 72. The combined number of yellow and red marbles is 72. 72 red and yellow marbles combined. You want to work out the number of red marbles in the 80 and the number of yellow marbles in the 80 and then add them. I want either one. So because you want either one, you add them. Red or yellow. Yeah. But understand that? But good? All right. So remember, guys, generally speaking in statistics, if a question asks you for the probability of something or something else, you're going to add the probabilities. If you ask for the probability of something and something happening, and you're going to multiply the probability. And the probability of getting a red and a blue from 2 draw. So the probability of getting the red and the blue, you're going to multiply the probability of getting the red with probability of getting the blue. So remember this, guys, for probability at this level. Or you're going to add the probability. Or means that you add the probability. And means that you multiply the probability. So for example, the probability of A or B becomes equal to the probability of the A plus the probability of the B. Right? But the probability of A and the B, you want the two of them to happen now, becomes the probability of the A times the probability of the B. So, or you add and you multiply. So look out for that. And the AND situation is like something followed by something. Something followed by something is all consecutive events is also an AND situation. There. This happened and then that happened, back to back. That's an AND situation as well. And all right. So remember, and you multiply or you add. Probability of something or something, or add the individual probabilities. Probability of something and something is happening. Both of them, this and that, or this then that. You multiply the probability. You want this, then that. You multiply the probability. You want this and that together. You multiply the probabilities. All right? That is it. All right, but good. Can move on. All right. Next question. The map and scale question. This question says a map is drawn on a scale of 1 to 20,000. That means 1 centimeter on a map is 20,000 centimeters on the land. That's what that means. It says, them say on the map, 1 centimeter represents n kilometers. And I want us to find what that value of n is. In other words, we need to convert the scale into a centimeter kilometer comparison. So we can set up like this. So they give us 1 centimeter. They give us 1 to 20,000 as a scale, right? It means that, what does that mean? It means that map to land, map to actual, is 1 centimeter on the map, because distance on the map will always be in centimeters, guys. They're going to measure meters per map, because meters is a piece of paper in front of you. They're not going to measure in meters on the map, they're going to measure in centimeters. Distances on the map are going to be measured in centimeters. So 1 centimeter on the map would now represent 20,000 centimeters on the land. Centimeters. That's what it means. You want to know what the 20,000 centimeters is in kilometers. So you convert the 20 centimeters to kilometers. So you can know what 1 centimeter on the map represents in kilometers. Now I like to carry the meters first. And you must know that 100 centimeters make a meter. So divide by 100 first. So 1 centimeter divided by 100, you get 200 meters. Right? Why did that? Because remember now, right here, from here to here, we are using the fact that 100 centimeter is equivalent to 1 meter. So if you have centimeter and 1 meter, you divide by 100. And then now the other conversion now, we're going to make kilometer. What we're going to use? We're going to use the fact that 1,000 meters is equivalent to 1 kilometer. So if you have meters and you want to get kilometers, you have to divide by 1,000. So therefore, the 1 centimeter on the map is going to be divided by 1,000. 1, 2, 3. The decimal point comes in front. This is the 2. So that's going to be 0.2 kilometers. And that becomes a scale for distance. All right? That's a scale for distance. So the n. So we get 1 centimeter to 0.2 kilometers. So this n that they said is 0.2. Let's say n kilometers. N kilometers. The n is 0.2. But I say that n is 0.2. Let them say no. We must find the distance on the map in centimeters, which corresponds to an actual distance of 4.8 kilometers. So it's a scale this now. This is a scalar or like a ratio. We're doing a ratio question now in a sense. So watch this now. What do we know from this? We know that 0.2 kilometers corresponds to 1 centimeter. I'm reversing the scale. I'm just reversing the scale. I'm just putting the actual side first to the map side. And 0.2 kilometers is that. I want to know from this ratio, what is 4.8? So I can divide by the 0.2 first and see what 1 is, and then multiply by 4.8 to see what 4.8 is. So you can do a thing like this. Divide by the 0.2 first. Divide by 0.2 first. I'm going to get 1 kilometer to 1 over 0.2 centimeter. What is 4.8 more want to know? So to get the 4.8, I'm going to multiply by 4.8. Now that we know what 1 is, we can now multiply by 4.8. So I carry down to 1 first, and then we multiply back up to 4.8. So I get 4.8 kilometers then becomes 1 over 0.2 times 4.8 centimeters. Multiply this by 4.8. When you do this calculation, you're going to see what it is. So it becomes 1 over 0.2 times 4.8. That's 24 centimeters. So 4.8 kilometers is 24 centimeters. So this is 24 centimeters. All right? So use the same scale to do the conversion. That's not the only way to do it, guys, but that is it. All right? I'm going to build up this number until we reach 4.8. Let's multiply it up until we reach 4.8. And that's, I could say, what number I need to multiply this by for it to become 4.8? And that will be 24. Get me? All right. Anyway you want to be. Next part now says, the actual area in square kilometers of a lake that is 12 centimeters square on the map. So remember now, when you have a map, when you have a distance scale, and want to convert it to an area scale, you're going to square it. You have to square the distance scale. Let's do it right here. So shift this over a little bit. Let's do it right here. So you have a lot of space. All right, watch this now. So we have the distance scale. Distance scale is 1 centimeter to 0.2 kilometers. To get to the area scale, so we can do area calculation, we square the distance scale, just square the value, square the side here and square the side here. That's all you have to do, guys. So the area scale becomes the scale that we're going to use for area. It becomes 1 centimeter square. Because if you square that one, it becomes 1 square, one same way. And when you square the centimeter, it becomes centimeters. Then now we've got square the 0.2 there. So it becomes 0.2 squared kilometers squared. Now that 0.2 squared is actually 0.04. So it means that 1 centimeter squared on the map is 0.04 kilometers squared on the island or on the land. And that's what you get from the distance scale to the area scale. Remember, guys, just square it. Square this one. Square it. Just square everything. Square the two sides of the scale. And to work in area now, we're using this. So if you don't want to know what 12 centimeters squared is, we'll just take the scale and multiply by 12. Multiply this now by 12. Because the question wants to know what 12 centimeters squared on the map would be. So multiply the area scale by 12. So multiply this by 12. You're going to see that 12 centimeters squared this times 12 is how much? 4.8, 0.48. Let's see. 0.04 times 12. Yes. 0.48 kilometers squared. This is the answer right here, sir. This is the answer for the question. 12 centimeters squared on the map is 0.48 kilometers squared on the land. Right here. 0.48 kilometers squared. But understand that. All right? So remember, if they give you the scale that they give you will always be distance. Scale that they will give you will always be distance. And if you have the distance scale and you want to get the area scale, you just square everything, square the values. Just remember that when you square the 1, it stays 1. So when you square this side, it becomes 1 centimeter square. And so you have to square this side as well to get this. And then this now becomes your area scale. Scale for area, for calculating area. Area from map to area on land, or area on land to area on map. This is the scale you're now working with. For area. Call it the area scale. Because I will always give you the distance scale, the scale for distance. Get the scale for area, you just square the values of the distance scale. All right? That is it. This question down here, so no. So this question says, the diagram below shows a running belt, EFGHIJE, that revolves around a running road on a treadmill, a running board, sorry, on a treadmill in the diagram. So this is like somebody going to be running on this treadmill, right? And that's the belt. Going around as the person runs on the belt, right? So it's always good when you think of it realistically. Just put it in real life. It becomes easier. All right? It says EJI, that's over here, and HGF over here those are semicircles. So they have 2 semicircles at the end of the belt. And the diameter is 0.07. So to give us the diameter, 0.7, not 0.0, 0.7. So it means that the radius over here, so the radius of this semicircle are 0.35. Half of this, right? That's the diameter, and that's the radius. But I give it that half of 0.7, 0.35. We like to work in the radius. All right? Then it says we must use pi equals 22/7, calculate the length of the belt. So length of the belt is going to be these 2 long sides plus the 2 half circles, don't it? 2 half circles make a whole circle, don't it? That's all. And the circumference of a circle is 2 pi r, don't it? The length of the belt is going to become 2 times this plus 2 pi r. 2 times that plus 2 pi r. Let's do it right here. So length of the belt becomes equal to 2 times the long side, which is 2.1, plus 2 pi r. 2 times pi, the pi is 22/7, times r, the r is 3.5. So this calculation right here, so that we did, is 2 pi r. But that's not why it's 2 pi r. That's 2 half circles we have. Make a whole circle, don't it? Circumference, right? So put this in the calculation, we're going to get the length of the belt. Let's put this all in the calculator. So it becomes 2 times 2.1 plus 2 times a fraction, 22/7 times 3.5. 26.2. 26.2, what is that? Meters. 26.2 meters. That's the length of the belt. 26.2 meters. It says, Glenda uses, that's what she said. Glenda uses the equipment to exercise 4 times a week. 4 times in a week she's using it. And she runs at 9 kilometers per hour. And she runs for 20 minutes each time. All right. Question says, calculate the number of complete revolutions of the running belt that the running belt makes during the week when Glenda is using it. All right. So we need to find is the total distance Glenda run and divide it by the length of the belt. So we can know how many revolutions she makes. We need to work out, yes? The radius is 3.5. Huh? God. Oh, sorry. Hey, my mistake. I have 7 stuck in my head. 0.35. So it's 2.6 then. No, that no. My mistake, guy. My mistake. I don't know why 7 stuck in my head. So I'm gonna change this calculation here. 0.35. So 6.4. Oh, good thing on the bright. My mistake. I have 7 stuck in my head, guys. Yeah, right out here and still use 3.5. All right, so that is it. So it's 6.4 meters. All right, let's go again now. So we need to find the total distance Glenda run for the week and divide that by 6.4 to know the number of revolutions, right? Because each revolution is 6.4. So we have to work out the total distance that she run. All right, so the total distance that she run is first inside the speed and the time. All right? Let's do a simple breakdown. Because this 9 kilometers per hour really means 9 kilometers in 60 seconds. Don't it? At 1 hour and 60 seconds, don't it? So it does 9 kilometers in 60 seconds. But she running 20, not 60 minutes. Jesus. I'm head gone to the boy. 60 minutes. 60 minutes. 1 hour and 60 minutes. So it's 9 kilometers in 60 minutes, right? But she only run for 20 minutes. 20 minutes is 1/3 of the 60 minutes, don't it? So therefore, she running 1/3 of this distance. You can't see that. So this 9 kilometers per hour means she does 9 kilometers in 60 minutes. You agree with that? So she does 9 kilometers in 60 minutes. So she does 9 kilometers in 60 minutes. How much would she do in 20 minutes? 1/3. Agreed? Because 20 minutes is 1/3 of 60 minutes. Why I say that? Good? But I can't say that, right? Making it simple, right? So if she does 9 kilometers in 60 minutes, 60 minutes has 20 minutes in it. For each of those 20 minutes, you'll be doing 3, right? So like you divide this now by 3 to see how much you're gonna do in 20. Divide it by 3. To get this to come down to 20 minutes. It means that she does 9 kilometers in 20 minutes. So it means that each that 9, Jesus, 3. Why am I head gone today? Oh Lord. Right, she does 3 kilometers in 20 minutes, right? And she does 20 minutes every day. And she runs 4 times per week. So the total she does for the week is 4 times 3 kilometers. So she does 12 kilometers in the week. But I can understand that. All right? We're just trying to simplify it. So she does 20 kilometers. She does this amount per day. So look here now. This is the amount that she does per day. But she does 4 days in a week. 4 days in a week. Therefore, she does this per day. Therefore, in 1 week, she does 4 times 3 kilometers, which is equal to 12 kilometers. This is per week. That's what she does per week. 12 kilometers per week. All right? And so watch this now. The key thing now is that this is in meters, guys. The belt is in meters. So we're going to have to convert this 12 kilometers into meters. So we can divide it by the length of the belt to know the number of revolutions. But understand that? See that? So the total distance run is 12 kilometers. But the length of the belt is 6.4 meters. So we have to know how much 12 kilometers is in meters. Divide that by the 6.4, because we cannot divide 2 different units, right? So therefore, see here now, the number of revs become the total distance traveled, which is 12 kilometers, divided by the length of the belt, which is 6.4 meters. Convert this to kilometers now. It becomes 12,000 meters over 6.4 meters. And that's going to be the answer. 12,000 divided by 6.4. So it's 12,000 over 6.4. So she does 1875 reps. 1875 reps. It does. You go with it? Understand? Anything you don't understand? So we have to work out the total distance that she did. I will get the total distance from the speed. Right? But the total distance from the speed. So she was doing 9 kilometers per hour. So we say, okay, since I want the time in minutes, we're going to break that 9 kilometers. I say, okay, the 9 kilometers is really done in 60 minutes. So she does 9 kilometers in 60 minutes. Then she clearly does 3 kilometers in 20 minutes. So each time she runs 3 kilometers. But she runs 4 times per week. 4 times 3 is 12. So she runs a total of 12 kilometers in a week. But the belt is 6.4 meters long. So you want to know how many reps it makes. Every rep it makes is 6.4 meters. So if we convert all the 12 kilometers to meters, and then you divide that number by the length of the belt. And that's the number of times the belt have to go around when she runs. Understand? Go work it over again. CSEC like to set these measures. Yes. All right? Let me focus because I kind of know so. I can't get my back to the way I'm not focus good enough. Anyway, that finishes that question. Let's go. We'll come to number 7, the pattern question. So this question gives us this pattern diagram, 4 shapes, and I want us to complete the shape. So if you look at it, I am seeing, look what I'm seeing. I am seeing that they added this. To this original shape. That's what I'm seeing. See? You take this and add it on to the bottom here to get this. Because this top part here so stay the same. This top part here so is the same as it was up here so. So that this top part here the same. And I keep adding, I'm going to say they keep adding this to the bottom. All right? So the next shape is to take this, and add it to the bottom of this thing down as well. To form the next shape. But I agree with that. That's what I'm looking at. Other people might see it differently, but no problem. Once they find out answer the same. So, well, firstly, I have to draw back. Let me delete this now. I'll move this out here a little bit. Firstly, I have to draw back this shape over here, sir. Right? I have to draw back that shape. So, what is missing? What is missing? I'm going to complete this block right just first. And it's like, this I have right now. This is what I have right now. So I need about this piece under here so to complete that shape. So I'm going to copy that down. I'm going to draw it on there in blue and copy it down. So this shape is missing. So that shape is missing. I'm going to put back this shape to complete the original shape, the 4th shape. So put this back down here to complete the 4th shape. I'm now back at the 4th shape. Oh, it's a little bit bigger down here, so no problem. Right? Let's draw this a little bit better. So I'm now back at the 4th shape, guys. I just need to add back now one of these. to get the fifth shape. Don't understand? Now this way you're going to have to draw in the exam. I don't have to draw it because I have the device. So I can do it like that. But essentially, that's what you need to draw. That's what you need to draw. So if you draw that, you're good. So you're supposed to have 1, 2, 3, 4, 5 of those lines. And then look at half piece on top here. So if you have that, you're good to go. However you set it up. But that's what you're supposed to have. So the blue is what I use. The blue is what I use to get back to shape 4. And then the red is what I put on now to complete shape 5. But that's not enough. So I got back to shape 4 with the blue. And then now I put on the red. It's the additional piece now to make shape 5. That's what that means in this diagram, right? Very good? All right. Yeah? Oh. And down here now, we have to complete this table, right? The same thing all the time. Complete this table. So the information up here is always the same. It's tell you about the table, it relates to the shapes and what have you. And I want us to complete the rows 1, 2, and 3. And then there's an additional question down here. So let's see now. So I like to complete the formula line first as usual, especially in the type where you're adding the same number of values each time. So here, they're adding 2 each time. So the formula starts with 2n down here, 2n. And the first value has 3, is 3. 2 times 1 is 2. You have to add 1 to make the formula. If you're not sure, you can try the second value on it. 2 times 2 is 2. It's 4 plus 1 makes 5. So you can try the values on it if you like. Then this one now going up by a 5, right? It's going up by a 5. So the formula starts with 5n. But the first figure has 10. So 5 times 1 is 5. You have to add another 5 to it. So it's 5n plus 5. This one going up by how much? This one going up by 2 as well, right? This one increasing by 2. So the formula over here starts with a 2n as well. But the first figure has 8. So you have to add 6 to make it. If you're not sure, you can try the second value on it. 2 times 2 is 4. 4 plus 6 is 10. So that formula is correct. So now that you have the formula, you have to actually help on the next line. But this is the next shape. So they make it easy for you by giving it the next shape. So you can continue the trend of adding 2 to this one to make 11. Add 5 to this one to make 30. And they have already added the 2 for that one. So we're good to go. Then to get the value for here, what we're going to do is put this formula equals this thing right here. Put the formula equals that over here. Let's do it over here. So for this line, we're going to put the formula equals 47. So we're going to put the 2n plus 1 equals 47. Subtract the 1, we're going to get 2n equals 46. Divided by the 2, we're going to get n equals 23. So the value right here is 23. Very good? I can check it. 23 times this 5 give you what? 23 times 5 is how much? 115. 115 plus 5 makes 120. That is correct. Let's put the 23 on this now. 2 times 23 is how much? 46 plus 6 is how much? 52. So the value over here is 52. 52. All right. And to get that value, we just put the formula on it. So we did 2 times 23 plus 6. Just to show we got that value. And the table done, right? Table done. Next one it says, Marla says she can make one figure that has exactly 502 squares. Explain why she is incorrect. So these are the squares. What do you know about the square? Hmm? The number of squares is what? No, but why is this number not possible for the number of squares? You're saying it because the number of squares is always odd. The number of squares is always an odd number. And this is an even number. See that? You can just tell them that. The number of squares is an odd number. Eh? If what you have mean that too, they will accept it. What answer, my dear? What did you say? What did you say? What you could have done by calculation, no, what you could do is say, okay, put this equal 502. And you can't get an integer number for n. You can't get a whole number for the n. That's it. And then accept that. Right. So the n has to be a whole number. So you can tell them that. But looking at it, what jumped out at me personally is that the number of squares is always odd. Because remember, you have an odd one up here. So see that? See it? So total number of squares is always odd. Okay, I keep adding 2 squares each time and start over with the odd number. See it? So I'm going to say the number of squares is an odd number. And 502 is not an odd number. 502 is an even number. Yes? When we finish this paper, we're done. I did say we're going to do a 5 o'clock. I did say 5 o'clock. It's 4 o'clock now. We're going to finish before 4 o'clock, actually. 4 5 o'clock. All right? We're going to finish long before 5 o'clock. So anyway, for this one, I would say the number of squares must be odd. All right? $502 is not an odd number. That's why she's incorrect. Because 502 is not an odd number. 502 is an even number. But number of squares must be an odd number. You can see it. But that's a formula, or that's an expression for an odd number, 2n plus 1 or 2n minus 1. I gave you that. When I gave you the possible formula that they must know, I gave you that one. 2n plus 1 or 2n minus 1 is a notation for an odd number. Right? So the number is always odd. So then they're always odd. I can see it on the shape too. Is an odd one out. I keep adding 2. So there's always an odd number out. So the number of squares is always an odd number. 502 is an even number. That's the reason why. All right, the number of squares must be an odd number. Must be an odd number. 502 is not an odd number, it's an even number. That's why she's incorrect. Or she's giving an even number as a number of squares. Not possible. All right. That question done. So 3 more questions to finish. We're finish before 5 o'clock. Unless we stop to talk about something. This question says F and G are defined as this is F and that is G. So F is a quadratic, G is a line. But this F is only valid for x greater than or equal to 0. So it's from 0 onwards, right? It says we must find G of -1. So we're going to plug the -1 in the G function. Now this is the same as f of x equals x squared plus 3. And this is the same as G of x equals 2x plus 2, right? Remember that. Same thing. So that's what we are familiar with. That's what they give mostly. But yes, they can give it like that as well. And I want G of -1. So I'm going to put the -1 in that. So G of -1 becomes 2 times -1 plus 2. That becomes 0. And side 0. That's a -2. -2 plus 2 is 0. But I go to that. Then I want f to the -1. That's the inverse of this one. F to the -1. Let's do it here. So I'm going to start by saying the f equals x squared plus 3. I'm going to inverse it and get x equals f to the -1 squared plus 3. I was trying to make this f to the -1 a subject. So take the 3 and carry it over here first. Let's continue up here. So we're going to get x minus 3 equals f to the -1 squared. And then to get rid of the square root both sides. square root both sides. We're going to get the square root of x minus 3 equals f to the minus 1. All right, and it's a positive square root because they did say that the x is greater than 0. So you form the inverse function, this has to be greater than 0. But let me not get into that. That's for higher level. You're not concerned with that, right? All right, that's what's gonna happen. So this means that f to the minus 1 of x, then put it by the of x now, is equal to the square root of x minus 3. That's what they're looking for, square root of x minus 3. Anybody got that? Anybody got this for the answer? Oh, okay. I'll come there and beat them with that do the stick, you know. Whenever I get it. All right, that's it. Then they want us to find g of f of x. That means f into g, right? That means f into g. Let's do it right here. F into g. So we have the f equals x squared plus 3. And we have the g equals 2x plus 2. And so we say we want to have g of x. So g of f of x. It means the f into the g. So it means that we're taking all of this f. I want to bring it and put it into the g right there where the x is. That's f into g. All right, that's what we're constructing right now. That becomes equal to, we're going to put back the 2. Where that x is, we're going to put back x squared plus 3 there now. Put all of the f there. And then put back this plus 2 at the end. And we'll simplify this. If we expand this out, we're going to get 2x squared. We're going to get 2 times 3 is 6. 6 and 2 is 8. Plus this 2 make 8. That's the answer right there. 2x squared plus 8. So we can write it right here. So g of f of x is 2x squared plus 8. That is it. Next part now says f of g is equal to this. Not g of f, no, f of g. Notice the reverse. F of g is equal to this. Solve this equation. Solve this equation. So we're solving f of g of x equals 2g f of x minus 15. All right, that's what we're solving. So the f of g is this one. So this one coming on the left side right here. So that's f of g. So that is 4x squared plus 8x plus 7. Let me shift this over. So we can have an equal sign here. Then we're doing the 2 times the g of f. So we're doing 2 times this. That was the g of f. Let's put it. Equals 2 times the g of f, which is the 2x squared plus 8. 2 times the g of f. And we're subtracting 15 over here. Minus 15. You better go to that. I was solving that for x now. Expand it out and solve it. This stays 4x squared plus 8x plus 7 equals, expand this bracket. We're going to get 4x squared plus 2, 8, 16 minus 15. So what happens now is that this x squared term, 4x squared here and 4x squared here cancel each other, right? Better go to that. And then now, this 7 goes over here. Now, firstly, this 18, not 18, that 16 I'm supposed to write. 16, 2, 8, 16. 16 minus 15 is 1. So this over here becomes a 1. Then a 6 will come over here and subtract from it. We're going to get a negative 6, right? 1 minus 7 is negative 6. We're going to get 8x. 8x equals negative 6. Now divide by the 8. You're going to get 8 equals negative 6 over 8, which becomes negative, divided by 2, 3 over 4. That's the answer. X equals negative 3 over 4. That is it. This is just some algebra, guys. Let's set up one equation for it to solve. Solve. There's nothing to it. This is not even come like months. So just create an equation, we will substitute what you know into it, and just solve for it. That's just some algebra. Right? That's it. The next part now says, use the graph to plot the f function and the g function for x greater than or equal to 0. All right, so plotting the graph. Like we're plotting the two curve. We're plotting the f and the g, right? So the f, remember, is x squared plus 3, and the g, remember, is 2x plus 2x plus 2. We can plot the line. The line is the draw. You can just do the line straight, and we can plot a couple points for the curve. And see, we only need 3 points. Well, 4 points. 0, 1, 2, and 3. 0, 1, 2, and 3. All right, so ready. Let's do the line first. The line easy. This is the line. It passes 1, pass through 2, y-axis intercepted 2. So it pass through here, so it's a gradient of 2. A gradient of 2. So for this curve, for this line, the gradient is 2. Huh? The gradient is 2, guys. And that gradient of 2 is same as 2 over 1, right? Which means rise 2, run 1. So the rise 2 units, run 1, right? So from here, we're going to rise 2, run 1. Remember, you're not rising grid, you're rising units. So this is 1 out, all the way to say 1 enough. So if we're going to rise 2 from here, you're going to come up to 4. Run 1, you're going to come all the way out to here, so that's a point on the graph, right there. So rise 2 again, you're going to come up to 6. Run another one, you come all the way over to here, so that's another point on the graph, the line. Rise 2 again, you're going to come up to 8. Run 1, you're going to reach over to 3 over here, so those are the points on this line, on the G function, which is that straight line. But go to that. Cool. If you want plot points and calculate coordinates, fine. But I like to just use the graph. Because when you have the y-axis intercept and the gradient, you put on the y-axis intercept, then use the gradient to rise and run to find other points. Easier. You don't need to be calculated. All right? You just do that rise and run on the graph. So those points are on the line. So a straight line through those points are good. So I'm just going to go like this. That's my line. All right? That's my G line. That's my G. Let's do the curve now. The F. Let's do the F now. So for the F, I'm just going to plot a couple points. So x equals 0, f equals 3. Everybody can say that? That's all? Or the y value is 3. We're doing the F. We're doing the F over here. So if x equals 0, yes, so the y equals 3. Next one. X equals 1. You put 1 here, so you get 1 squared. 1 plus 1 squared is 1. 1 plus 3 is 4. So we're going to get f equals 4. Same as y equals 4. Then put the x equals 2. 2 squared is 4. 4 and 3 makes 7. The fy equals 7. Next point, 3. X equals 3. 3. 3 squared is 9. 9 and 3 is 12. So we're going to get f equals 12. So those are the points. Let's put them on. Let's put them on a different color. Perfect. So 0, 3 is 1 point. 0, 3 is going to be right here. Next point. 1, 4. 1, 4. 1, 4, 0. So same point as that one. 1, 4. Next point. 2, 7. 2, 7 is right here. See? 2 up 7. 2, 7 is this point right here. Remember the quadratic curve, you know? It's just half of the curve you have. You don't have the full curve. Next point. 3, 12. 3, 12. 3 out to 3 up to 12. That's this point up here, so. 312. And then you just join the curve. So you join a curve through these points like this. That line might be a tangent. I don't know. This might be a tangent. That's it. That's what I'm getting. Because actually half of a quadratic curve, guys. You go like that. It's actually half of a quadratic curve. Right? So I'm going to leave that as the answer, as my graph. So like this is a tangent point right here. That's a tangent point. That's a tangent point. Then check it for no quick enough. What is it? X squared. So dy by dx would be equal to 2x. And x equals 1. Dy by dx equals 2a. The tangent. The tangent for true. It's a tangent. So the blue line is a tangent. So if they ask what's the relationship between the functions, the blue is a tangent to the f. This is the f function. So this is a tangent point. That is it. Very good. So this will plot some points, all right? Number 9, 2 questions to go. Number 9 says, the diagram below shows a quadrilateral OM, quadrilaterals OM and N. Quadrilateral M and N are the images of O after it undergoes two different transformations. So what is the original? The original one, O, right? So O over to M and O over to N. So O to N clearly is an enlargement, right? It's to this an enlargement. And we're going to figure out what the other one is. That one. All right, we're going to figure that one out. Let's see what they say. All right, it says, describe fully the transformation which maps O to M. All right, so O to M clearly is an enlargement. You can literally see it. If you compare this length and this length, it's a doubling. So the scale factor is at 2. All right. Additionally, they're pointing in the same direction. So for example, this side up here, so it's pointing so, corresponding side is pointing the same way. So the positive 2 scale factor. Next thing we need now is the center point. Where's the center of the enlargement? So the center of the enlargement is on the line joining the corresponding point. So these 2 points are 2 nice points to use. So they are on this line first. Right? Now, because the scale factor is 2, I can know that this is the point. Because the distance here is doubled to here. The scale factor is 2. So I can know that that is the point. But the best way to actually find it, the other way to find it, is to join 2 other corresponding points, like where? Like, that right? Like this point, that on that correspond. That's not right, Mr. Shaw. I'm going this way, the other way. The point is below. It's the other way. Let me extend this down. But the enlargement is this way, so the point is down here, so the other way. So it's the other way it is. So I'm going to join this to the other way. Somewhere down here. So it looks like about here. No, not there. Here. So this distance is double to there. All right. So I can join 2 other points, like for example, here and here. Join them and extend it, right? So it's gonna go this way. Something like that. So you see, right here is the center of the enlargement for real. All right. So that point is -1, 1, -1, 1, -1, 1, -1. If I join 2 other points, you're gonna get the same thing. If I join, for example, here and here, it's going to go like this. So that same center. So we know it's an enlargement of scale factor 2 about this point. That is it. That is it. So that is it. All right, so I'm gonna write that here. So this transformation right here It's an enlargement of scale factor to about the point 1, -1. Or you could say with the center at 1, -1. Nobody got that? All right, good. Next part, let's know what single transformation maps O to N. O to N. That's this one to this one. All right, let's look at it. That looks like, if I join these two corresponding points, like so, and I join these two corresponding points, like so, it looks like I have rotated 180 degrees about the origin. See that? Let's join two other points. If I join these two corresponding points, these two, like so, they're going to pass through the origin. If I join these other two, which other two are doing this and this? Join them like that. So yes, that's what it is. A 180 degrees rotation about the origin, or a reflection to the origin. Same thing. But I say that it's a 180 degree rotation about the origin, or a reflection to the origin. Same thing. So I can tell them that's what it is. A reflection to the origin, or a 180 degree rotation about it. So this one is the 180 degrees rotation. I don't have to give the direction. Clockwise and anti-clockwise is the same. There's a 180 degrees rotation. If you want to put clockwise, I want to put anti-clockwise. This time it don't matter. And a 180 degrees rotation clockwise and a 180 degree rotation anti-clockwise is the same result. So put whichever one you want, right? So 180 degrees rotation clockwise or anti-clockwise. Do it your choice about the origin. I could also say the reflection to the origin, or you could say a reflection through the origin. Remember, 180 degree rotation about a point, it's the same as reflecting through the point. That's what the second one is. All right, then down here it says now, on the diagram, it says above, but it's actually below. Draw the image of O after it undergoes the following transformation. So we're going to do a -5, 2. So remember, -5, 2 means 5 to the left and 2 up. That's what it means. 5 to the left, 2 up. So moving this thing, 5 to the left, 2 up. Let's do it. 5 to the left, 2 up. So we're going to do this point. Just move this point and then draw by the same shape around that point. 5 to the left, 2 up. 1, 2, 3, 4, 5 to the left, 2 up. 1, 2 to here. That's 5 to the left and 2 up. At this point coming to here. And you're going to draw by the same shape of O around this point. We're going to put this little diagonal piece first. Let's draw it in purple. Just here. I'm going to put this other diagonal piece, which is across two boxes, over to here. I want to draw this diagonal piece up here, which is across two boxes vertically again, up to here. I want to put this piece now to connect them, which is there. No, that's like a curve, Mr. Shaw. That's it. And if someone label it what, I always tell you what to label. But if someone label it L. So label this one L. That's what you're supposed to get, everybody. Next one, them must reflect O in the line y equals minus x. Now, y equals minus x is a horizontal line. That's first thing. This line is a horizontal line. Y equals minus x. So y minus x. Y equals minus 1. So y equals minus 1 is a horizontal line down here. So I'll put it out the way. This was what again? 1, -1, this point. All right, so y equals minus 1 is going to be this line. Draw it in third. This line across here. So that's the mirror line. Y equals -1. I reflected this in that line, y equals -1. All right. So let's put the image in blue. So firstly, this point to the mirror line going to go 1 point on the other side to here. This 1 point at a time. And this point is 2 to the mirror line is going to go 2 on the other side to here. And this point is also 2 to the mirror line. This one is 2 to the mirror line. Gonna go 2 on the other side to here. That's where it's going. Here. All right. Let's see. And this point now is 1, 2, 3, 4 to the mirror line. It's gonna go 1, 2, 3, 4 on the other side. To here. And we're joining these points. So join these two. Join these two. Join these two. And join these two. And that's it. Looks like a reflection period. This reflect to this line. So you see, do your transformation 1 point at a time. All right, that is it. Now someone label this last one, label it P. So this is P. So when you're done, guys, that's where the diagram is supposed to look. So the P is supposed to be there and the L is supposed to be there. That's what you're supposed to have. If you don't have that, much marks for all of these. They will have the marks here where you're supposed to have for each one. All right, that's what you're supposed to have. Do your transformation 1 point at a time. Next question says, oh, so that is it. That finishes that question. This question says, a buoy B and a lighthouse L are 95 kilometers apart. It says the buoying of B from L is 230 degrees. So from L to B is 230 degrees. It means that from here, we turn to the right 230 degrees, go around the sun to get the direction down to B. So B is somewhere down the sun. And that angle is 230 degrees. It says use a scale of 1 centimeter to 10 kilometers. So it means that the 95 kilometers, if you're using 1 centimeter to 10 kilometers, then the 95 kilometers is gonna be a 9.5 centimeter line. You see that? 9.5 centimeters. So we need to construct a 230 degrees and a line that is 9.5 centimeters. That's what you want. So when you're done, it's supposed to look like this. It's supposed to look like, oh, you're saying the wrong thing. Within a 9 centimeter line, 230 degrees. So 230 degrees clockwise. So our line is gonna go somewhere down here. So we have to measure it, and if you use a protractor and measure it. Or you can get 230 degrees. You can do it piece by piece. Or you can do 230 degrees. 230. It can be 40 below this line. 40 degrees below this line. To get it. 230. I can add it up little by little. Right? You can add it up little by little. So you have 180 there, so 230. Can get down here, so it would have been. So extend this line down and then measure this at about 50, 50. 50 degrees in it, so. Right? If you want to. Or you could say, okay, put in a horizontal line away as a 90, and you want 40 below to get the 230. Everything around here so is 270. Right? So if you want 230, you can subtract 40 degrees from this line. We have to use the protractor to do it. The protractor won't have 230 on it. But that's what I'm trying to say. You want to get a 230 degrees around here, so you can build it up. You can say, okay, put a line across it to make 90 and measure 40 down here, so. And so the line down here now gonna be 230. Measure 40 down here, so. Your choice. But anyway, suppose to end up with a line going like this. And you're gonna put B down here, so. The line is supposed to be 9.5 centimeters long. That's why I'm going to draw a line that is 9.5 centimeters long. And the angle around here is supposed to be 230 degrees. To make that angle 230, you could also measure the angle inside here. What that's going to be? 360 minus 230 is how much? 360 minus 230. What's that? Huh? So you could measure 130 degrees away there too. A protractor can measure 130 degrees. You could measure an angle here so that is 130 degrees instead. Measure 130 degrees over here. So measure this one. Measure 130 degrees here and put in the line. And they measure this line 9.5 centimeters long. You represent your 95 kilometers. But the question so is on a scale of 1 centimeter to 10 kilometers. So 9.5 centimeters would represent 95 kilometers. But I said that is 1 to 10, right? 1 to 10. All right, so this will be equivalent to your 95 kilometers. So that is what it's supposed to have on your diagram. Something looking like that way though. Measure this angle for 130 degrees. That's a nice way to do it. The protractor. Right? So I could have put the thing on this line, put the protractor on this line. Like so. That's a protractor. And you're reading up for 130 degrees up here. So reading up for 130 degrees on your protractor up here. So. But I understand that. That's what they put it. Measure 130 degrees this way. Put the base on this line. I measure 130 up here. 130 up there. 130 degrees up here. The protractor. That's how you would do it. All right. So if you didn't do it before, go and do it again. Well, follow CSEC. So they didn't put any straight bearings question on this paper. They don't put any circular measure, circle theory on it. Notice? No bearings, no circle theory. They just want us to measure an angle. They didn't ask us to do no bearings calculation. We didn't get any. Let me see what number 10 is. One question left, right? So the question kind of weird. I wanted to one change it because this transformation question usually come at the last question. Kind of weird. Usually come at the last question. And they didn't put any transformation in section 1. There's no transformation in section 1. So you see the paper a little bit different, guys. All right. So no matter where they put the question, you have to just do them where they put them. But it kind of structure a little bit differently this time. That's what I'm noticing now. Let's answer this question and we'll call it a day. So give us a vectors question here. So it says the diagram shows triangle OPR. M is the midpoint right here. And N is the midpoint right here. Looks like a vector. Yes, it is. All right. It says OM is U and ON is V. So they give us these two vectors. Now, we can populate the diagram as we go from now. Since this is the midpoint on this line, and the vector from O to M is U, means that from up here, so is another U. Same thing down here, so this vector down here, so is V, and this is the midpoint, and this is the same length, same direction. So the vector over here is another V. So we have V right here, so A U right there, so. So all of this are 2U, the whole of this are 2V. So we have those position vectors. It's a must get the vector Mn. So because we have the two position vectors, we can just use O times the last minus O times the first. So this is OM, no, ON, O times the last is ON, the last is N. ON minus OM, put on the vector house. So the ON is V minus the OM is U. We look at the diagram as well. You go from M to N, you go minus U, because you're going to opposite direction to U, plus V. Oh, by the way, they didn't put arrows on this diagram. Let's put them on. The arrows are this way and this way. So they didn't put on the arrows, you put them on, right? It's OM. Then the one NP. So we can use O time last again, O time the first, because we have the ON is V and the OP is 2U, obvious. So the OP is 2U, so we're good to go. So we can use last minus first again. This becomes OP minus ON. The OP is 2U minus the ON is just V. See there, to go from N to P, to go from N to P, we'll go minus V, see the minus V there, and then plus 2U, plus 2U, so the plus 2U there, that is it. All right, then it said, no, show that MN is parallel to PR. MN and PR. We don't have PR yet. We have MN already, so we need to calculate PR now. So we have Mn already. Mn is the vector V minus U. We now need PR. So what is PR equal to? Can we get it from the diagram? E to R, yeah. Because we know OR is 2V and we know OP is 2U. So again, we can use O times the last minus O times the first. What are easy question again? Them get OR minus OP. Why are you supposed to get 100% on this paper, you know? The OR is 2V and the OP is 2U. That's what the PR is. So you say if you multiply this by 2, it becomes equal to that, right? If you multiply this by 2, we'll be able to equate. So this now will be 2mn equals 2v minus 2u. And then these two things will be equal. And so these two things now equal. The PR is 2 times mn, which means that they are parallel. So when we equate, you shall see that the big one, PR, is 2 times the shorter one, mn. This means that they are parallel. Therefore, PR is parallel to the mn. The vectors are parallel, so the lines are parallel. PR and mn, let's see. PR, that's this line over here, parallel with this line over here. Those two lines parallel. You can see it on the diagram as well. Question done. They will come to some major series business over here. All right, so they don't put no ratio up on the line for that one. Just straightforward. Open and get a paper like this one. We get a paper like this one and kill it, don't it? Huh? Yeah, man. This time get January gone. Question says the matrix P written in terms of A. The only thing on this paper I would say is the base question, which is not very frequently set, and maybe the rotational symmetry, but you should understand the rotational symmetry now, right? And the base question, just you, whatever base they give you, put the place values. There's base 3, 3 to the 0, 3 to the 1, 3 squared, 3 cubed. Those are the place values. I know what those values are. All right? Base values is the key for the base question. All right. So this matrix says, it says A is real as follows. So this is a vector, this is the matrix P. Calculate the determinant of P in terms of A. Calculate the determinant. Determinant is this product minus this product, right? So the determinant of P equals this product, which is 3a times 2a minus this product, which is 6 times 4. Just worked out one time. This is 6a squared minus 24. That is it. 6a squared minus 24. Says determine the values. Say values meaning plural, two values, more than one. Determine the values of a for which p is singular. Remember, if p is singular, it means it has no inverse. They could have said that. Determine the value of a for which p has no inverse. And it has no inverse because the determinant is equal to 0. So we're going to put this equal to 0 because it's singular. So it becomes 6a squared minus 24 is equal to 0. So divide 2 by 6, you get a squared minus 4 equals 0. You could transpose and get a squared equals 4. But when you calculate square root now, you have to remember plus or minus as a key. So the a equals plus or minus 2. Just prove what is supposed to get plus or minus 2. Another reason why it is plus or minus 2, I can show you right here. This part of the equation. So I say this side is a difference of 2 squares. The a squared minus 4 is the same as a minus 2 times a plus 2 equals 0 if you factorize it. But I say that. So if this factor equals 0, then you get in a equals 2. And if this factor equals 0, you get in a equal negative 2. So that's why I have the plus or minus 2. All right? So you could have done it this way as well. That is it. It says, determine p to the minus 1, the inverse of p, for which p is non-singular. So if it is non-singular, we're going to get in terms of a. We're not going to actually get it. We're going to get in terms of a, because a is already in the value. We don't know what a is. All we know is that if a is singular, if the p is singular, then a going to be one of these values. Right? And it says no, determine inverse of p for which it is non-singular. In other words, they are saying it has an inverse. We have to get it in terms of the a same way. So it becomes 1 over the determinant where this is the determinant times the adjoint. You have to leave those expressions in the answer. Right? I don't know what the a is. So the p to the minus 1, the p to the minus 1 becomes 1 over the determinant of the p times the adjoint of the p. The determinant of the p, we just have to put the 6a squared, 6a squared minus 24. This determinant of 6a squared minus 24. 6a squared minus 24. Multiplied by the adjoint of the p. So to adjoint the p now, we interchange these two. The 3a and the 2a, switch them around. So I'm going to put 2a up here, so, and 3a down here, so. And then these two other values on the second, they're going to leave them where they are, change the sign. So this 4 stays and becomes a negative 4. This 6 stays and becomes a negative 6. So we're going to have negative 4, negative 6. I will leave that this time, because really not supposed to be dividing each of these by this. But I think if you leave that as the answer, 6 will give you a marks. Leave that as the answer. All right? That's p to the minus 1. I want to hear what grade going to get in. Somebody have one like to know how rush out of this. Next one down is us. It's a right on 2 by 2 matrix will represent a counterclockwise 90 degrees rotation about the origin. See? This question, some question give you, some question expect you to know it, just know the man done. It's an anti-clockwise 90 degree rotation matrix about the origin. This means that the negative one is at the top. See it here? The negative one is up here, so at the top. 1 down is a 1, 0, 0. Let me call it x. X equals that. See it there? Easy to remember. That's an anti-clockwise 90 degree rotation about the origin. Show that all the time. Next one. They want a counterclockwise rotation about the origin, 90 degrees. That's this matrix. Followed by a reflection in the y-axis. This is the base for reflection in the y-axis. So what they want is this. Look what they want. They want an x followed by a Q. X followed by Q is, what is X followed by Q? QX. It means that the T is equal to QX. The T, what them say it becomes is equal to Q times X. That's what we calculate. Q times X. X followed by Q is Q times X. Compound transformation. So the T equal going to multiply the Q times the X. Minus 1, 0, 0, 1 times the 0 minus 1, 1, 0. Roll that out and get the answer. So 0 times that is 0. And 0 times this is also 0. That's a 0 right here. And the value out here so now is this time this is 1. And 0 times 0 is 0. It becomes a 1 out here. So 1. And down here so now is this row and this column. Gonna get a 1. 0 times 0 is 0. 1 times 1 is 1. So down here is a 1. And it's gonna be a 0 as well. Because it's 0 times 0, 1 times 0. That is it. It's supposed to be a negative 1. It's a 1. Okay. And this matrix, which matrix is this? Which matrix is that? Which matrix is that? Y equals X. Fiction like Y equals X. Y equals X. Reflection matrix. Reflection in the line. Y equals X. Y equals X reflection. That's what that is. Come now, come now, come now, now, pack up. Let me hear how much I get you packing up. Huh? Send the 4. All right. By the way, I have class tomorrow evening, everybody. I think at 4 o'clock. Tomorrow evening, 4 o'clock, will come and just do a couple of things for the exam. How much you get? How much you get? How much you get? What how much you get? All right. Online students, send me a WhatsApp of how much you got. Send me a WhatsApp of how much you got, guys. That's what I take exam paper. How much you get? You don't do none of that paper then. The paper you don't do. So what? One exam you want to do? When you have a chance to jump, or one time you don't jump, I will chop me. They don't want to do the exam paper for the exam. Which mock exam you do? You know, no mock exam you do. Every week you do. Show me nobody, show me nobody, show me nobody. When you pass the exam, if you don't do none of the mock exam then. When you find if you don't do none of the mock exam then. You want to pass the exam. Eh? Oh, 69. Look here, you have to try go over the question and make it wrong. You over all the questions you got wrong. You over the questions that you got wrong. Redo the questions you got wrong, guys. Redo the questions you got wrong. All of them similar. Not supposed to. I see. I guess maybe it's supposed to. If it's supposed to be similar to this, I am on the same level, mind you. Yes, they are. Much I go. What you get? What? About the 8% don't get sick. What? One good man. What you get? Alright. How much? 6-0. That's a jump from the last time.
The jump maybe the ones to the where look at that percent.
Suppose to. Give me a money right in here. Oh, never put that. So still go on do what this time you get wrong for my please. My weapon. You hear me? Go on do what this time you get wrong. Oh. Alright, I'm gonna send the video in the group. No, man. Alright, bye everybody. Tomorrow we'll have a session. Tomorrow evening. Is that bring your question session tomorrow? Bring your question that you want me to explain session tomorrow. Bring your question that you want me to explain. Bye everybody online. Much again. You have to go and finish the paper, my youth. Now we have 4 sharp. Exam peace, man. You can't wait for exam day for doing paper. How much you get? All right, finish session now. Bye everybody.